Morning, I'm Mike from ODS Marine. Purpose of this video is just to explain some current work we've just completed on Belmont Lake down here in the lower end of the conservation area. We did installed tension anchors on the dam on Belmont Lake. That process involved 8 anchors, 7 of, I believe, 1¼ diameter. The anchors themselves were 27 feet long. They're into bedrock approximately 15 feet. Varied a little bit just as the rock was up and down a little bit on the surface, like on the bottom of the dam itself. One anchor, the 8th anchor, is a little larger diameter. It's on the very end of the dam. I believe that one was installed to be a larger diameter anchor, as that end's not in the bedrock in that area. It's a little more fractured and there's more rock piled up against the end of that dam, whereas the other end is into a very hard bank of granite. It took 8 days to do the initial stage of drilling through the deck of the dam and the bedrock. And then we regrouted the holes. Due to the fact that we're losing, what we do is it's called a water test. We try to fill the hole completely full of water to the top of the dam to indicate that we're not going to lose grout out any fissures through cracks in the rock, or if there's a crack in the concrete. We seem to be losing most of our water right at the transition between the dam, the concrete itself, and the bedrock, because we could measure down the hole to determine where our water level was at. And that's just, you know, we maybe perhaps don't have 100% of a bond from concrete to rock, which it takes very little of a gap to lose water into. Once we regrouted the holes, the grout was drilled back out again. Holes took approximately 5 days to drill the concrete or grout back out of the holes. And we had 100% seal on all holes. We were able to fill water right to the top of the dam, and it stayed there. Hard concrete of the dam and then down through granite. Core samples were all brought here. The rock in almost all the holes was very hard. A couple of the last holes there was a little bit more fractured. You can see that in the core samples, but it is all granite rock. It tells us how hard the rock is, what type of rock we're drilling through. Therefore, when we're grouting the tension rods in, we know if we're in a lot of broken, fractured rock or if we're in pretty solid granite. And for the most part, it was very solid granite. A couple of the holes closer to the one end were a little bit fractured, but again, when you pump the grout into those, it goes into the fissures and seals as well, so you get a very good bond into it. We mixed our grout up and pumped the holes through a grout pump, an air-activated grout pump, to fill them up completely with grout. And then we used what's called a spider crane. We were able to drive it down on the dam and set it up in a very limited amount of space, and yet still get the reach to be able to handle these anchors. Anchors themselves weighed approximately 200 pounds. And being 27 feet long would have been an issue to try to stand that up to lower it in the hole. The crane we had, the small spider crane, could have a pick reach of 28 feet. We were able to pick the anchors completely up, standing straight up, and lower them slowly down into the holes. So it was a very specialized piece of equipment that can be used inside of buildings or anywhere where limited access is, where you can't get a boom truck or anything that has any lift capacity to it. We lowered the anchors in at a very slow speed, just as, you know, we're displacing the grout as the anchor's going in, so you don't want to drop it in there too fast and cause air pockets or anything else. The one day we did 4, lowered 4 anchors in, and the other 2 stages were 2 anchors each kind of afternoon, as we were pretty much following the drillers along with it. So we had to wait for them to be out of the way, complete for drilling, so we could do the next 2 type thing. But effectively you could do 4 a day easily installing them. Normal conditions, they say 3.5 days, and at that point you're able to set anchors, do the tensioning. Now we purposely left it for 9 days. We left the extra time, and that part of that was in coordinating with the technicians who were doing the tensioning, the time frame that they needed to arrive here, and we wanted to give it extra time for these anchors, for the grout around the anchors to harden. Just the weather was a little cooler. Still in the acceptable limits, of course, but better to give it a little extra time than to be trying to tension when you're right on that line, that limit, because if something were to break and come apart, then you're redoing the whole thing. It's a hydraulic activated, it essentially works like a jack. It threads onto the rod and literally draws tension against the rod and the concrete structure of the dam. And they'll bring it up in stages. Start off at 25% to 50 to 75, 100, 133%. And then they hold it there for a certain time frame, 10 minutes per stages. And then they'll release to 100% load into a lock-off. And what they do for the lock-off is essentially the large diameter nut that's sitting on top of a steel plate is tightened, and then the pressure is released. That holds it at that said pressure, and that's where it is for eternity. The tensioning that was done on that anchor was done to 200% of its load, as they normally do on one anchor. The rest of the anchors were all set to 133% of the load on the tensioning, and then the tension's released slightly and they're locked off at 100%. All of our anchors here set very well on the tensioning. So there is a certain amount of slippage you're allowed to have, an acceptable level with these anchor systems that are used. And the technicians from Dag International were operating the tensioning device. We had 2 anchors that had a small amount of slippage on them, all within the acceptable limits. The other 6 had 0. There was no slippage at all. Like, it's a very hard rock. Good, perfect situation for doing this. We finished the rest of the tensioning with the technicians. At that point, the remaining rod that was sticking out past the tensioning, the anchor nut, was cut off. And you have to leave a certain amount of rod sticking up for them to be able to get a hold of with their tensioning jack. That's cut off, and then we mix up a grout mixture to recap the holes. So the plates and the nuts and everything themselves are completely under concrete cap. Everything's sealed back up again, so that now your deck is nice and smooth again. And really, other than the color difference between the grout and the original concrete there, you wouldn't even know anything had happened. It was drilled with a diamond bit through a core bit. Marathon Drilling did the drilling for us. It's a hydraulic powered drill. When we get them, literally it's fully encased into almost like an ABS plastic with a sealed grout in between, The end that we're going to be tensioning on is covered in grease, really thick grease. So once we're done tensioning, that's all sealed, and then we recap the surface of the deck with an epoxy grout, a concrete grout in there. So everything's completely sealed. There's no way for the two things that you need to cause rust essentially are moisture and air. So usually the rebar inside of any concrete structure won't rust until it becomes exposed to the air. So as long as it's all sealed, there's no way for the elements to get at it and it won't rust. So these anchors will never rust. They'll be there for the life of that dam. We used a specific product made by Sika. It's recommended from the manufacturers of Dewey Dag International for these anchor rods to use this type of product. Purposely, I guess, for the strength of it and the drying time. The concrete around those anchors is harder than the dam. I think initially we were hoping that the first drilling would be all we'd have to do. It wasn't necessarily anticipated having to regrout the holes and re-drill. Now, from speaking with the drillers from Marathon Drilling, that is a fairly common thing. So I guess it wasn't anticipated, but maybe sort of expected. It was expected from the drilling company side of things. That added some extra days to the program. In total, the program, with the extra set time that we left for the grout, went to about 4 weeks. I think initially we were hoping to do it about 2.5 maximum, so we added probably an extra week and a half to our program just from the extra drilling point and leaving for the extra setup time on the grout. You're bound to lose a certain amount of flow through holes or cracks like that. The concrete on the dam itself is in excellent condition, so we weren't expecting to lose anything there, and we didn't. It was just more at the transition zone between the two where we were kind of losing and we wanted to make sure that we weren't pumping grout out anywhere where it didn't need to go. So any sort of a crack or fissure that was there was literally filled in with grout, so essentially concrete minus the stone. So we, through the whole process of establishing these anchors in the dam and everything, it's made the dam a lot stronger. There's no chance now of the dam slipping or tipping over. And again, makes it a lot more solid into place, less chance of any movement which would cause cracking, stress fractures in the dam. There's nothing to be done to them at all. They're completely in place and sealed. Again, like you don't even know they're really there, other than a little bit of a different color. And imagine once the grout does take its full cure, it's probably turned to pretty much the same color as the original concrete too. So you really wouldn't even know anything was done to it. The results we got were excellent. The technicians from Dewey Dag were very happy with it, thought it was an excellent job, so that's what we were aiming for.